Okay, today we're going to continue with 5.1. We're going to talk about some more things with angles and then some circular and linear motion. The first thing we're going to talk about is the area of a sector. And what a sector is just a piece of the entire area of the circle. We're going to be using this formula here. A stands for area, R is for the radius, and theta is the angle in radians. So that's the important part. If it's given in degrees, you're going to have to use convert it over to radians. We also did have the formula for arc length, and we're using S is equal to R theta for there. Again, R is for radius, theta is an angle in radians. So let's take a look at example 1. It says find the area of the sector of a radius of 3.5 feet formed by a central angle of 65 degrees. So I know that area is equal to 1/2 times the radius squared times the angle, but this angle happens to be in degrees and we need to convert that to radians, and the conversion factor is pi over 180. At that point it becomes calculator work, and we should get the area to be about 6.95 feet squares. It also asks us to find the arc length, so that's S is equal to R theta. Again, the radius was 3.5. We know the angle is 65, but we have to convert that over into radians, and there's our conversion factor of pi over 180. At that point, again, calculator work, we get about 3.97 feet. If you look at example 2, the central angle measured is 3 pi over 8 radians. So now I know I'm in radians, and even if this word wasn't here because I see the pi in there, I would know it is radians. It has a radius of 4 centimeters. What is the area of the sector? And then 1 is the arc length. So again, area is 1/2 the radius squared, so 4 squared. Since this is already in radians, we don't have to worry about any conversion factors. Calculator work, we get the area to be about 9.43 centimeters squared. Then to find the area of the sector, that is the radius of 4 times the angle in radians, which it already is. And when I multiply all that out, I find that to be about 4.71 centimeters. Okay, so the next thing we're going to talk about in this unit is angular and linear speed. When we talk about angular speed, I'm asking, as something is going around and around and around, how many radians are being swept as we go around each time? I'm going to do all of these problems using what we call dimensional analysis. So the problem says, assume a hard drive on a computer is circular and rotates at 7,200 revolutions per minute. They want to know what is the angular velocity. Velocity is another word for speed in radians per minute. And on the side here, I just want you to kind of show where you want to get. So we want to get to radians per minute. If I look over here at my formula, we're already in minutes over here, but what I got to get out is those revolutions. And if I think about how many radians are in one circle, we learned this in 5.1, there are 2 pi radians in one revolution. So there's your conversion factor. I want to get the revolutions out. I know there are 2 pi radians in one revolution. And that's great. Now the revolutions cancel out. What I'm left with is radians per minute. And what I get here is 14,400 pi radians per minute. That's an exact answer. If you go ahead and get the decimal form of that, it would be 45,238.93 radians per minute. Both answers are acceptable there. Alright, so that's angular speed. Linear speed is talking about if you have a circle and you just kind of roll that circle out, you would get a certain length. And then you rolled out the circle again, you'd get another length, and kept rolling out the circle. How fast is speed going? A common thing that we use for linear speed, that if you think about, is a car. When we drive, we talk about miles per hour. So it says the radius of each wheel is 15 inches. That's a good thing to keep noted. If the wheel is turning at a rate of 3 revolutions per second, So I'm at 3 revolutions per second. How fast is the car moving? And I want to express my answer in both inches per second and miles per hour. So inches per second and miles per hour. So let's start with inches per second. I already have the seconds in here, which is great, so I don't have to worry about time, but I do need to get those revolutions out of there. And the one thing that's going to get us out of revolutions into some kind of linear speed is circumference. So circumference is 2 pi r, and that is the perimeter around a circle. So in one revolution, I'm going to get how far around it is, and that's going to get me either feet or inches or meters. It's going to get me out of revolutions into some kind of linear type unit. So I know that in one revolution, there are 2 pi r inches in the car. Now, the radius here is 15, so that's going to be 30 pi inches. Don't forget you got the pi in there when you're doing your calculations. Revolutions cancel out. I'm left with inches per second, which is great. So that's either going to be 90 pi inches per second, and that turned out to be 282.74 inches per second. Then they also asked me to get this same answer in miles per hour. So I want to take this here, 90 pi inches per second, and I need to get myself into miles per hour. So let's just deal with the inches first. So I need to get miles in. I see it's in the numerator here, so I need my mile to be here. Well, how many inches are in a mile? There's 5,280 feet in a mile, and there's 12 inches in each foot, and that gets us 63360. This is something you are going to be able to do on your own. We will not be giving you these conversions. So I know there's 63360 inches in 1 mile. I also need to get rid of these seconds. So the inches are gone, which is great. I've got the miles. That's what I'm looking for. I want my seconds to turn into hours. So I'm going to need an hour in the denominator, 1 hour. And how many seconds are in an hour? There's 3,300 seconds. Seconds cancel out. And so now I've got my miles per hour. At this point, you're multiplying through the numerator, dividing by the denominator, and you should be getting about 16.07 miles per hour. All right, let's continue on the next page with a couple of more examples. Example 5 here. Spin balancer rotates the wheel of a car at 480 revolutions per minute. If the diameter of the wheel is 26 inches, so that's going to give me a circumference of 26 pi inches. That is our gateway to get out of revolutions into some kind of linear speed. And I want to know what this is going to turn out in miles per hour. So over here on the right, we want to get from revolutions per minute to miles per hour. First thing I need to get in there are those revolutions. I think it's a revelation last time, but I do mean revolution. So in 1 revolution, there is 26 pi inches. So out go the revolutions. I'm now into some kind of linear speed, so some unit. I also know that I don't want inches, I want miles. So I want miles to be in the numerator, so I got to get rid of these inches. And before we said they are 63360 inches in a mile. And I also know I want my minutes to become an hour. Notice the hours in the denominator, so I need 1 hour down here. There are 60 minutes in 1 hour. So now the minutes cancel, and I can see that I'm now in miles per hour. Multiply through the numerator, divide by the denominator, and you should get about 37.13 miles per hour. At how many revolutions per minute should the balance be set to test a road speed of 80 miles per hour? So now I'm starting at 80 miles per hour, and now I want to get to revolutions per minute. Okay, so let's just kind of deal with a couple of things. I see and I know that my circumference is in inches. So the first thing I want to do is get rid of these miles and get everything back into inches so I can get a conversion back into revolutions. So I know in 1 mile, there's 63360 inches. All right, so I got the miles out of there. I also know I want to get out the inches and into the revolution. So in 1 revolution, and our gateway to get from revolution into that length or distance kind of thing is circumference. So we said that that is 26 pi inches. Now we've got the inches out of there. And the last thing I need to do is convert hours into minutes. So I need the hour out, so that's going to go in the numerator. And I know that there is 60 minutes in an hour. So the hour is now gone. I'm back to revolutions per minute. And in the calculator, you should get 1034.26 revolutions per minute. Just a clue, when you're dividing in your calculator, I put parentheses around. That's your multiplications there. Okay, let's try another example. We've only got 2 more to go. At a cable car museum, you can see the 4 cable lines that are used to pull cable cars up and down the hills of San Francisco. Each car travels at a speed of 9.55 miles per hour. So I'm in miles per hour, caused by a rotating wheel whose diameter is 8.5 feet, so that's going to help us there. How fast is the wheel rotating? Express your answers in revolutions per minute. So we again want to get to revolutions per minute. I could see that the circumference is going to be in feet. So the circumference here is 8.5 feet. So I want to get out of miles into feet so I could use that conversion factor there. So I've got 5280 feet in 1 mile. So my miles are gone. I also know I want to get into revolutions. So in 1 revolution, there are 8.5, whoops, got the pi over there, pi feet. So 8.5 feet. So now I've got the feet gone. So I've got the revolutions. Now I need to just get rid of the hours and get into minutes. So in 1 hour, I know the minutes have to go in that denominator. The hours go away. I'm down to revolutions per minute. Calculator work. You should get 31.47 revolutions per minute. All right, so let's try the last example. It's a 2-parter. We've got a riding lawnmower, has wheels that are 15 inches in diameter. So I know that the circumference is going to be, 15 pi inches, which are turning at 2.5 revolutions per second. So we're at 2.5 revolutions per second. They want to know what is the angular speed of the wheel. Since it doesn't say what time unit to be in, we're going to keep that in seconds. So I want to go to radians per second. So this is an angular speed. Remember we said there are 2 pi radians in 1 revolution. These guys cancel out. And what we've got here is either 5 pi radians per second. You could also convert that out. It'd be 15.71 radians per second. And then they say, okay, well, how fast is the lawnmower traveling in miles per hour? So I know I'm at 15.71 radians per second. And I want to get myself over to, let's see, miles per hour. And actually, the angular speed's really not going to help me here. So let's not start with this. Let's start with our original one, or 2.5 revolutions per minute. So let's get rid of this guy right here. And let's start with, 2.5 revolutions per second. Okay. So again, I need to get the revolutions out of there. So in 1 revolution, we already said there are 15 pi inches. revolutions are out. I want to go to miles, so I got to convert these inches into miles. I see miles is in the numerator, so the mile is going to be up here. We have 63360 inches, so inches go away. And the last thing I need to get is seconds into hours. See the hours in the denominator, so that's where it's going to be here. There are 3,600 seconds. Those guys cancel as well. And what we're left with now is miles per hour. And when you put this in the calculator, you should be getting 6.69 miles per hour. Okay, and with that we conclude 5.1.